Dear students, welcome to IIT JEE NEET classes. This is Ashok, Chemistry faculty. Today I am explaining Chemical Bonding chapter 2026 January session JEE Mains questions. The question is given below are two statements. Statement 1, the number of species among SF4, NH4 plus, NiCl4 2 minus, XCF4, PTCl4 2 minus, SEF4 and NiCN4 2 minus that have tetrahedral geometry is 3. Out of these molecules, only 3 molecules having tetrahedral geometry, that is statement 1. Then statement 2, in the set of NO2, BeH2 and BF3 and AlCl3 molecules, all the molecules have incomplete octet around central atom. In the light above statements, choose the correct answer from the options given below. See, according to statement 1, the species SF4, the central atom is sulfur. Sulfur belongs to 16th group. So, the valence electrons in sulfur atom is 6 valence electrons. It is equal to group number. But it is bonded with 4 fluorine atoms. 4 fluorine atoms. Each fluorine contribute 1 electron. So this is total 1 orbit, 2 electrons. So that this is s orbital, p, p and p. These two belongs to d orbital. So that this is what sp3d hybridization having 1 lone pair. Generally sp3d hybridization is trigonal bipyramidal. Now 1 lone pair, that lone pair present at a equatorial position. So that is SF4. So because of due to presence of 1 lone pair, the trigonal bipyramidal structure is shifted to seesaw structure. So that SF4 molecule has seesaw shape of the molecule. Similarly, SEF4 also. SEF4 here also selenium, same sulfur group. So that valence electrons 6. So it is bonded with 4 fluorine atoms. This is also containing sp3d 1 lone pair. So that SCF4 selenium tetrafluoride also containing seesaw shape of the molecule. So SF4 and SEF4 both belong to sp3d 1 lone pair. So both are seesaw shape of the molecules. Next, NH4 plus molecule. In that NH4 plus molecule, the central atom is nitrogen. Nitrogen belongs to 15th group element. Valence electrons are 5. But it has 1 positive charge. So remove 1 electron from valence state. Now it has only 4. Bonded with 4 hydrogens. 4 hydrogens. Each hydrogen contribute 1 electron for bonding. So that we have, this is s orbital, p, p and p. So this is belongs to sp3 hybridization, 0 lone pair. So that sp3 hybridization tells us tetrahedral geometry. So that NH4 plus molecule has tetrahedral molecule. NH4 plus has tetrahedral shape. Geometry is tetrahedral. Next, NiCl4 2 minus molecule. In that nickel has valence electron configuration 4s2 3d8. But here nickel configuration is, this is Ni plus 2 oxidation state, that is 4s0 3d8. So d orbital has 8 electrons. 8 electrons, but chlorine is a weak ligand. So because of that weak ligand, these 2 electrons not pairing due to presence of weak ligand, no pairing. So that 3d orbitals not involved in hybridization. After 3d, 4s and 4p orbitals given space involved in hybridization. So this 4s and 4p orbitals undergo hybridization. 4 sp3 hybrid orbitals are formed. So nickel can shows 4 sp3 hybrid orbitals. All these 4 sp3 hybrid orbitals bonded with 4 chlorine atoms. 4 chlorine atoms, so that NiCl4 undergo sp3 hybridization. NiCl4 undergo sp3 hybridization, that is tetrahedral arrangement, that is NiCl4. So tetrahedral geometry. So NiCl4 2 minus has tetrahedral geometry. Nickel undergo sp3 hybridization. So NH4 plus and NiCl4 2 minus both undergo tetrahedral geometry. So here SF4, SCF4 is a seesaw arrangement. This is also seesaw arrangement. So NH4 plus and NiCl4 2 minus both are tetrahedral arrangement. So then XeF4. In XeF4 molecule, xenon is the central atom which belongs to 18th group. Valence electron is 8 valence electrons. 8 valence electrons. It is bonded with 4 fluorine atoms. Each fluorine contribute 1 electron. So that the remaining electrons, 2 electrons become 1 orbit. That is lone pairs. So this is s orbital, p, 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 d, d. So that this is belongs to sp3 d2. Total 2 lone pairs. 2 lone pairs. Generally, originally sp3 d2 is what? Octahedral. In this octahedral containing 2 lone pairs. Because of the 2 lone pairs, it will become square planar arrangement. So XeF4 is square planar arrangement but not tetrahedral. This is square planar. Square planar. Hybridization is sp3d2 hybridization. The next molecule is PtCl4 2 minus. Here platinum atomic number is 78. This configuration is xenon 4f14 5d8 6s2. So here platinum oxidation state is +2, Pt +2, that is xenon 4f14 5d8 6s0. So in platinum, the valence electrons present in 5d orbital. Generally, in 3d orbital element bonded with a chloride ion or bromide ion or iodide ion or fluoride ion and fluorine, chlorine, bromine, iodine and OH minus ions and all bonded with 3d orbital containing elements. Generally what happen? If the metal belongs to 3d orbital, that metal atom bonded with fluorine, chlorine, bromine, iodine and OH minus ions, so electrons does not pairing takes place. No pairing takes place, electrons. No pairing takes place. No pairing takes place. So these ligands acts as poor ligands, weak ligands. But in platinum, the electrons present in 5d orbital. So when this platinum bonded with chlorine, bromine and iodine, here partial pairing takes place. Actually 5d8, 1, 3, 4, 5, 6, 7, 8. But here pairing takes place because the platinum having the valence electrons in 5d orbital. So in 5d orbital partially pairing takes place. So one d orbital is still available for bond formation. This d orbital, then 6s and p orbital undergo hybridization. So now what is the coordination number? 4. So how many chlorine atoms are there? 4. So that's we required 4 orbitals. So 5d and 6s and 2 6p orbitals undergo hybridization, form dsp2 hybridization. So in PtCl4 2 minus, platinum undergo dsp2 hybridization. That means dsp2 means square planar arrangement. Square planar arrangement, that is. So this is square planar arrangement of PTCl4 2 minus. So here you remember one thing, if that central atom of a metal atom is 3D series element, rearrangement of electrons not takes place. If it is a 5D series element, rearrangement of electrons takes place. Based on that, PTCl4 2 minus shows square planar arrangement. The next molecule is NiCN4 2 minus. In NiCN4 2 minus, nickel undergo +2 oxidation state. So the valence electron configuration is 4s0 3d 8. Then Cn is strong ligand. So that because of strong ligand, the 3d8 electrons undergo rearrangement. So electrons undergo rearrangement. Then further, this 3d orbital and 4s orbital and 4p orbitals, we required we have 4 ligands, so we required 4 orbitals, so that these 3d and 4s and 4p orbitals, one 3d, one 4s and 2 4p orbitals undergo form dsp2 hybridization. So here cyanide ion given electrons. So NiCN4 2 minus undergo square planar arrangement. Square planar. So if you observe statement 1, SF4 is seesaw structure, NH4 tetrahedral and NiCl4 also tetrahedral, XCF4 square planar, PTCl4 2 minus also square planar, and NiCN4 2 minus also square planar, and SCF4 is seesaw. So that we have how many tetrahedral? Only 2 tetrahedral, but they given 3. So that this is false statement. In statement 2, in that that is molecule NO2 molecule, then BeH2 molecule, then BF3 molecule, then AlCl3 molecule. In NO2 molecule, nitrogen atom has 7 electrons. So in BeH2, beryllium has 4 electrons. Then in BF3 molecule, boron has 6 electron. Then aluminum also has 6 electrons. So that all are having electron deficient. So in statement 2, all the molecules have incomplete octet around the central atom. So statement 2 is correct. So statement 1 is false, statement 2 is true. So option 3 is the correct option. The next question is given below are 2 statements. Statement 1, the correct order in terms of bond dissociation enthalpy is chlorine, bromine, fluorine and iodine. Once we'll check that. If you observe the bond distance between the fluorine, chlorine, bromine and iodine, between the fluorine atoms, the bond distance is very near. So that here some repulsions will arise between 2 fluorine atoms. That's why less energy required to break between 2 fluorine atoms. But in chlorine, sufficient distance is there. That's why to break the chlorine atom between the chlorine molecules, we require more energy. Then again in bromine and iodine, the distance is somewhat more, so that we required less energy compared to chlorine and iodine. So the correct order is chlorine, then bromine, then fluorine, then iodine. Why fluorine is lesser than bromine means due to presence of repulsions between 2 fluorine atoms. The 2 very close to each other, 2 fluorine atoms, some repulsions will arise. So because of that repulsions, less energy is required to break fluorine-fluorine bond atoms between the molecule. So less energy required to break fluorine-fluorine bond in fluorine molecule. So statement 1 is true. Here one important point you remember, that is bond energy increases by increasing bond order. So bond energy is directly proportional to bond order. Bond energy increases with increase in bond order. In statement 2, the correct trend in covalent character of the metal halides is SnCl4 is greater than SnCl2, PbCl4 is greater than PbCl2, UF4 is greater than UF6. So we know very well, according to Fazan rules, charge on the cation increases higher the charge on cation, greater is the covalent character. Greater is the covalent character. So that SnCl4, this is plus 4, this is SnCl2 plus 2, this is more covalent. Then PbCl4 greater than PbCl2, this is plus 4, this is plus 2, this is covalent. Then UF4, UF6. In UF4 uranium is plus 4, UF6 uranium is plus 6. Actually UF6 having more covalent than UF4, but they given UF4 is more covalent than UF6. So this is wrong. So statement 2 is false. So that the correct representation is statement 1 is true, but statement 2 is false. Option 1 is the correct. The next question is the correct increasing order of CH, CO, single bond O, C double bond O and C triple bond N bonds in terms of covalent bond length is. Generally, the bond length depends on bond multiplicity, that is single bond, triple bond, double bond, like that. Bond multiplicity and atomic sizes. Generally, triple bond is shorter than double bond is shorter than single bond. So this is purely NCERT based question. They given bond length values also in NCERT. So according to NCERT, CO single bond length is 1.43 angstroms. CH single bond length is 1.09 angstroms. C double bond O double bond length is 1.23 angstroms. C triple bond N triple bond length is 1.16 angstroms. In these two single bonds, CO is longer than CH bond length because between carbon and nitrogen, so carbon electronegativity is 2.5, oxygen electronegativity is 3.5, nitrogen electronegativity is 3.0, hydrogen electronegativity is 2.2. So that between carbon and oxygen electronegativity difference is 1, but between carbon and hydrogen electronegativity difference is 0.3. Here CH bond is shorter than CO bond because here the hydrogen is very small compared to oxygen and even carbon also small compared to oxygen. So that due to small size of hydrogen atom, the CH bond length is less compared to CO bond length. Even in CO bond, it is polar bond compared to CH. CO is more polar than CH. So the bond length in CO is more compared to CH. That's why CH is strong bond than CO bond. So the bond length order is CO single bond is more, then C double bond O bond length is more, then C triple bond N bond length is more, then CH due to small size of the hydrogen atom. So this is the correct bond length order. So that is CO is, this is B, C double bond O, this is C, C triple bond N, this is D, this is A. So A, D, C, B. That is second option is correct. The next question is, two p black elements X and Y form fluorides of the type EF3. The fluoride compound XF3 is a Lewis acid and YF3 is a Lewis base. The hybridization of central atom of XF3 and YF3 respectively are. So both are p black elements. That is, one is XF3, another one is YF3. So this is acts as Lewis acid. This is Lewis base. So Lewis acid means electron deficient molecule. Electron deficient molecule. Lewis base means electron excess molecule. Electron excess molecule. So XF3, here X is electron deficient. The central atom is nothing but BF3 molecule. So in that BF3 molecule, boron can form 3 bonds with a fluorine atom. Boron has only 6 electrons, that is less than 2 electrons. So not followed octet rule. This is electron deficient. Electron deficient. So in BF3 molecule, boron has sp2 hybridization, steric number 3, that is trigonal planar arrangement. Trigonal planar. Trigonal. But in YF3 molecule, this is Lewis base. Lewis base. That means it can donate electron. That's why Y is nothing but NF3. So here nitrogen atom has one lone pair. It is bonded with 3 fluorine atoms. So 3 bond pairs and 1 lone pair. So here steric number is 4. So this is belongs to sp3 and containing 1 lone pair. So it has trigonal pyramidal shape. Trigonal pyramidal. Trigonal pyramidal. So BF3 and NF3. BF3 is sp2 hybridization. NF3 is sp3 hybridization. So here X is boron atom, Y is nitrogen atom. It undergo sp2 hybridization. It undergo sp3 hybridization. So sp2 and sp3 is the correct answers. Option 2 is correct one. So the next question is, the formal charges on the atoms marked as 1, 2, 4 in the Lewis representation of HNO3 molecule respectively are. So here we want to find out formal charges of 1, 2, 3 and 4 atoms in the HNO3 molecule. If you observe that formal charge formula, formal charge is called valence electrons minus non-bonding electrons minus 1 by 2 into bonding electrons. bonding. So this is the formula. This valence electrons is nothing but group number of the atom. So what is the first atom here? Oxygen. So the first atom is oxygen. Oxygen valence electrons nothing but group number is what? Oxygen group number is 6 minus number of non-bonding electrons 1, 2, 3, 4 minus 4 minus 1 by 2 into bonding electrons. 2 bonds are there. Total electrons 4 electrons. So here 2 2s are 4, that is 6 minus 6 is equal to 0. So that first atom formal charge is 0. The second atom is nitrogen. So nitrogen group number is 5 minus number of non-bonding electrons 0 minus 1 by 2 into bonding electrons 1, 2, 3, 4. 4 2s are 8. So 2 4s are. So that 5 minus 4, that is plus 1. So nitrogen formal charge is plus 1. So then third atom, that is oxygen again. Here oxygen, the valence electron is 6 minus number of bonding electrons and non-bonded electrons, that is 1, 2, 3, 4. 4 minus 1 by 2 into bonded electrons 4. So here 2 2s are 4. 6 minus 6 is equal to 0. So that third atom also 0. The next again fourth atom, that is again oxygen atom. In this oxygen atom, so number of valence electrons is group number, that is 6 minus number of non-bonded electrons 1, 2, 3, 4, 5, 6. 6 minus 1 by 2 into bonded electrons 2 electrons. So that 2 ones are 6 minus 7, that is minus 1. So this is minus 1. So 1, 2, 3, 4 atoms formal charge is 0 plus 1, 0 minus 1. So the correct option is third option. So dear students, please subscribe the video and click on the bell icon and give good comment. Thank you very much.